So to continue, we are given this triangle, triangle DEF, and this triangle is bisected on all three sides by points A, B, and C. This triangle is an equilateral triangle and also has a defect which is beta greater than 0. So I'll write this right here, is the defect of the triangle. Now because these sides are bisected, these segments here are congruent, which I'll denote with a hash mark right here. However, in the Euclidean case, this would mean that triangles DAC, BCF, and EAB are all congruent equilateral triangles because these angles here, if DEF was equilateral, would be 60 degrees, and by side angle side, these would all be congruent and also be equilateral. However, because this triangle has a defect, beta, that is greater than 0, these smaller triangles must also have a defect, but must have an angle sum that is less than the larger triangle DEF. Therefore, these triangles are isosceles triangles, but are also congruent because these sides here are smaller. And these triangles' defects are alpha, alpha, and alpha, as given in the problem. Now, we are left with this inner triangle here, ABC, which is obviously congruent because of the corresponding sides with the outer triangles. However, this triangle has a defect gamma, and is therefore not congruent to any of these three triangles because it is smaller with a smaller defect. This is again contradictory to Euclidean geometry, in which all four of these triangles would be congruent equilateral triangles. Now, according to Lambert's, again, theory that a defect of a triangle is proportional to its area, it is obvious that these four triangles sum to create the area of triangle DEF, and therefore 3 alpha, the defects of these three triangles, plus gamma will equal beta, or the defects of all four smaller triangles, it will equal the defect of the larger one. And again, this is different than the Euclidean case, in which there will be no defect in the triangle because all of the triangles would have 180 degrees. And this is a just really nice way to highlight how the geometry is different, and obviously it's difficult to visualize because we're so used to visualizing in the Euclidean sense, but this does have a lot of applications, and with this defect here, beta greater than 0, this would be a spherical case, and this would be a triangle that you would see on a sphere, which obviously has a lot of implications.